Hey, David.
So how bad is it snowing over where you guys are?
Uh, well, none of it's sticking right now, but it will be tomorrow morning.
Yeah,
So,
I'm supposed to have an in-person session over in the valley later tonight. So that's why I ask. All right, so what do we got going tonight?
I sent you the
Yeah, I got it
thing.
here. And let's see, I can just do this. um, hmm, um, yeah, there's the Zoom. Yeah, there's the Zoom button. Boy, I only let you Zoom one time. Pretty amazing. Okay. Let me open my OneNote. Just a second. Thought I had it open, but guess I didn't. I want to put this left, snap left, and double click that. Now we're good to go. Okay. So how would you graph this? Minus 2 is greater than or equal to k.
Um, on the inequality, or
No, excuse me, my mistake, on the line chart.
yeah. Um, hmm.
In other words, here's 0. So obviously we need to find minus 2, correct?
Yeah.
Okay. And it's a greater than or equal sign. So we know it's a solid
So that's
dot there. Question is do I draw my line to the right or to the left?
to the right.
Actually, it's saying that minus 2 is always greater than k, which means k has to be in that direction.
Oh, okay.
You see why? Now,
Yeah.
the other way to look at this would be to turn it around and say k is less than or equal to minus 2. It's important that you see that those two are the same thing. And if you write it the second way, it tends to be a little easier to see graphically. In other words, now there's really not much question about how you would graph it. So that's kind of a trick on all of these, is get your variable on the left, only when dealing with inequalities. And you can see why, as it was a little confusing there. Let's see, we'll try this one. First of all, do we have an open circle or a closed circle at minus 4?
Um, open.
Correct. And now which way are we? Left or right from there?
Is it to the right?
Okay. As long as you keep making that mistake, I'm going to suggest that you turn this around. Excuse me. You didn't make a mistake. I did. Yes, it's to the right. My mistake. But I might be inclined to do this all the time. Just because we're so used to this, at least I am, I suppose it's just as easy to get used to having the variable on the right, but to me, it's harder to see. I'm sure that C will give you no problem. All right, real quickly, D, 1/3 greater than or equal to J. So where do we start?
Well, how would you mark down 1/3?
Well, that's just a point on the number line. In other words, if that's 1, then 1/3 is about right there.
Okay.
Closed or open dot?
Closed.
To the left or the right? Oops, excuse me. To the left or the right?
The left.
Now, is this what they're looking for, or are they looking for you to write J on there also?
I think what we have is fine.
Yeah, I think so too. I've never seen it where you had to label that. In fact, I'm not even sure that that's proper. All right. Let's go to 3. We have m minus 3 is greater than -6. That's the first step.
Mark down where -6 is.
Hold on. Always get your variable isolated is the first step.
Okay, add 3 on both
6
sides.
is the key point right now, but it's not going to be once we isolate that variable. So if I add 3 to both sides, I got this. What? And now we're back to where problem 2 starts, which is how do you graph these? So -3 is the key point. Circle, right or left?
It's to the, so -3 is smaller than m, so
I would tend to think that you're better off thinking that m has to be greater than -3. That instantly tells me which way to go.
okay.
So which way?
So if m is greater, then we want to go to the right.
Correct. You see why that's a little easier?
Yeah, I do.
It's just my thinking about it. Other people's minds might think a little different. But so this is kind of the same. We'll do one more of these, just a little bit more complicated. And although all it is more complicated algebra, it's going to come down to the same thing that's in 2. So let's clean this up. What do we end up with?
Well, we could,
Before we can graph it,
subtract 22.
be isolated, preferably on the left side. So tell me the steps.
Well, you could subtract 22 on both sides.
Okay. So now we got, here I'll just do it like this, -22. Okay, what next?
1 second. You could, is there any way to add -9 and 10 together? For -9, C
Sure.
and 10.
These are both apples. This is -9 apples, and this is +10 apples. I can combine those because they're like terms. In the same way, if that was X and that was X, I'd be able to combine them. If this was X and this was Y, I would not be able to combine them because now they're not like terms. So what does that combine to?
That's just C. Yeah.
And this combines to -16. And now graph it. Start where?
1 second. 0, So C is less than 16, so we want to go to the left.
First of all, we got to put another point on there. I got to label minus 16.
Yeah.
That was not, that's the 0 point. In other words, notice all these graphs have the 0 point on there. So you have to put this on there yourself. And then tell me open or closed dot, left or right, with all your answers. What is
open dot to the left.
Okay. All right. And let's do one more of those just to reinforce what we learned on that one.
Okay.
Clean this one up.
We could add 2 to both sides.
Okay. Now what?
We could simplify the right side.
Okay. Tell me what to write.
6 is less than or equal to 2a.
Okay. Next.
Could we divide both of those by 2?
Correct. And finally, let's graph it.
Okay.
There's the point 3. Tell me what's next.
So we're gonna fill in the dot and go to the right since a is more than 3.
Okay. What'd you say to do to the dot?
Fill it in.
Okay. Closed. And
yes.
Right, that's the same as a is greater than 3, so I don't necessarily have to rewrite it algebraically as long as I understand that. Okay. Let's try D. It's a little different.
You could multiply by -3 on both sides, correct?
Correct.
But you have to flip the sign.
So read me the next line.
W is less than -9.
Good. And graph that.
Okay, so it's an open circle over -9 going to the left.
Good. All right, I think you're pretty good on these. Let's see if we can find something more challenging for you. F is kind of funny. Look at F. F is nearly identical to D. In fact, it ends up being identical. It's going to be exactly the same graph. What's our first step going to be on E? As long as we're covering out.
E, we could go, oh, this one's weird. How do you solve E?
Well, you can do it in 2 steps or 1 step. The simplest way is to probably do it in 2 steps. What would step 1 be?
Get rid of the -3/5.
Okay, that you can do all of that in 1 step if you know what to do. But my inclination would be to do it in 2 steps. The first one being multiply by 5. The second one being divide by -3.
Okay.
Now, you could also multiply both sides by -5/3. Notice that that's exactly what I did in 2 steps. I divided by 5 to get rid of the denominator, or excuse me, I multiplied both sides by 5, and then I divided both sides by -3. Well, that's the same as dividing by -5, multiplying by -5, and dividing by +3. It's, in other words, what you have to do is multiply by the reciprocal. But that does give some people some problems, and so I think that the smartest way to look at doing these is in 2 steps. Just multiply by 5. That's a positive 5, so it doesn't change the direction yet. And now divide by minus 3. So we're going to get A is greater than plus 25. Now, if you prefer the one-step method where you multiply by the reciprocal of that, it does save you 1 step. In other words, if I were to multiply this by minus 5/3, I would still have to switch the signs, but I'm going to go immediately to this line next. So it's a 2-step process instead of a 3-step process.
Okay.
I kind of am going to leave it up to you, as long as you know both methods. And the most straightforward one is the one I did. In other words, whenever I'm solving equations or inequalities, my first inclination is I want to get rid of the denominator. Okay? And if there's a coefficient, I want to get rid of the coefficient. So I do that in 2 steps. But this one can be done in 1, just so you know. Now, let's go down and look at G. Okay. Next line. Let's read the lines for me. You don't even need to tell me what you're doing. Most of these are pretty easy, so I would expect they're not going to give you too much trouble.
So let's subtract 6 on both sides.
Okay, just read the next line. That's all I want.
Well, what do you mean?
The next line would be k over 3 is less than 1, right? Doing what you said. I subtracted 6 from both sides. I just didn't write it. In other words, I don't necessarily feel the need to do this every time I do that. I can subtract in my head pretty easily, knowing that I'm going to be left with whatever else was over there. And so 7 minus 6 is not tough. So to me, this is sufficient. There's nothing else that's required to be written. But if you're going to write every single step, these are the 2 steps that you get away with. Okay? And what's the next line?
That'd be k is less than 3.
Good. That's what I'm saying, is I don't need you to tell me that you're multiplying by 3. And how do we graph it?
We're going to put a open dot over 3 and scribble out to the left.
Okay. All right. Let's see. Did you send me just 1 sheet or 2? You sent me 2, didn't you?
Yeah.
Okay. I don't see anything on here that is going to give you any problems at all, including I. Let's look at the next sheet.
Okay.
Bless you. Now, if I just figure out how to look at the next sheet. I actually thought I was getting pretty good at this. And then all of a sudden I run into problems where I don't know what to do, and I have to do it the slow way. And one of them, in other words, something happened to my Gmail while we were doing that 1 sheet. I don't know what. But I can certainly get it back up again and look at the second sheet.
All right.
Yeah, here we go. Okay. I'll blow that up 1. read those?
Yep.
Nothing particularly difficult here. Just do one of them, so I haven't seen anything exactly like this yet. Next line.
-8 is more than y plus 3.
Okay. There's nothing wrong with dividing both sides by -2 at this stage. It's actually the proper thing to do. But if I'm dividing the left side by -2, I don't get -8. I get -2.
Oh, sorry.
All right. And, you know, you had two choices here. The other choice was to distribute that and then go from there. But it's actually a little better to do it this way, and I'll show you why. Notice that if I do it your way, I get -2 because I'm dividing 4 by that coefficient. I'm not multiplying both sides by -2. I'm dividing both sides by -2. Got to switch the direction of that. And I'm left with just y plus 3. And now what's the next line?
-5 is more than y.
Correct. Now notice the biggest number we're looking at is 5, doing it your way. If we did it my way, not my way, but the other way, because actually now that I look at it, I like your way better for this reason. If we do it the other way, already I've got a number greater than 5 right there. Okay. Now I'm going to get the same answer because I'm going to get this next. Then I'm going to divide both sides by -2. So there's my -5 greater than y. So I get the same answer regardless. But I do deal with bigger numbers, and there's a 10. So my view on arithmetic is that you generally choose the option that keeps your numbers the smallest, and your way kept them smaller. All right, let's do L.
Oh, all right.
I'll write it.
Oh, yes. So.
Okay, the next line. Ooh, interesting problem.
It looks like it's unsolvable.
Well,
no, I have to prove whether or not it can be, it's either solvable or not solvable.
Well, here's 4K on this. This is 4K and this is 4K, okay? So I can cross those out. In other words, I'm going to subtract 4K from both sides. And now the question is that a true statement that's left? Is -1 greater than -6? It is. On a number line. There's,
I wasn't
there's
thinking about that.
-1, there's -6. Well, -1 is to the right of -6, so it's greater than. So what they're essentially saying with this is that no matter what K is, it's a true statement. K could be 2, K could be 10, K could be 1,000,000. And -1 is always greater than -6.
So how do I graph that?
Well, it's the whole number line.
Okay.
In other words, the domain for K is all real numbers. I don't know. Have they taught you interval notation?
No, but we learned a little about the all real numbers and no possible answers and all that.
Right, and this is a strange problem because the variable goes away. But what that means in this case is that it's valid for all k. Now, had I come out with that, let's say that was the problem. Well, now that's not a true statement, right? So there's no k. It's null is the solution. Since minus 10 is never, ever greater than minus 6, then this original statement, after, with the minus 10, is not true no matter what k you use. You could use any k you want to pick, and it's not ever going to be true. So the graph of that would be the null graph. Nothing. However they want you to show that, but all right, let's try to get in one more. Let's see if we've got any other. Yeah, the next one is similar. Let's do it just as a, let's see if you can do this one start to finish.
All right.
First step?
We could multiply out 12 and 3.
Okay. Or you could do what you did before. In other words, that's going to leave us big numbers, but the other option is, how about we divide both sides by 3?
Okay.
That simplifies it a little bit, right? And keeps us from
Yeah.
having to distribute that and producing big numbers like 12 and 24. So if I divide both sides by 3, I've got this. Okay? Now you do kind of have to distribute the left side. There's nothing else simple that I can do on the left. So I'm going to distribute the left side, and I get this. And the right side says that. So now what?
It's equal to each other.
Okay, but what's the...
So that means all real numbers are true, right?
In other words, whenever you can completely eliminate the variable, you should. Okay?
Subtract 4x on both sides.
Okay. And now I've got a statement. Is this a true or a false statement?
It's true. No, false.
False. They're the same thing. If it was greater than or equal, then it would be equal, so it would be true statement. But as long as they've got a greater than, then that's null again. That is not true, meaning there is no value of x that would make the original function true. No matter what you pick, the original statement cannot be true. So it's a null set again, or however they want you to do that. All right, Mark, I will let you go and talk to you next Tuesday. It stopped snowing over here. Is it still snowing there?
Let me look real quick. It's snowing very lightly though, and it's not sticking. So
I'm going to go out. I'm going to make my meeting. Okay. Thanks very much. Talk to you later, Mark.
All right. Thanks, David.